Hello and welcome to another video of First Principles. In the previous videos, we proved this identity for multiplications of cosine half angles, which we showed is equal to sine of alpha divided by alpha. Now I want to use this identity to prove this formula for pi over 2. This formula is sometimes called Vieta's formula after 16th century French mathematician François Vieta. You may want to pause the video now and think a little bit about this problem and come back when ready. Okay, let's start from the identity for multiplication of cosine half angles as we saw, and put alpha equal to pi over 2 because I wanted to calculate pi over 2, and in the denominator on the right hand side I have this alpha. So I can actually use this formula with alpha equal to pi over 2 to calculate it. I know that for alpha equal to pi over 2, sine of pi over 2 is equal to 1 and cosine of pi over 2 or 90 degree is 0. So I plug in pi over 2 to the formula, to the identity, and I get pi over 2 is equal to 1 because sine of pi over 2 was equal to 1 divided by all these cosine multiplied together, which I basically like brought these cosine terms to the denominator. I brought like alpha to the numerators. So here we have like cosine of alpha over 2. Alpha is pi over 2, so it becomes cosine pi over 4. And the next term becomes cosine pi over 8, cosine pi over 16, etc. Now recall that cosine of theta is simply 2 times a square of cosine of theta divided by 2 minus 1. This is simply formula for cosine of double angle. So we usually see this formula as cosine 2 theta equal to 2 cosine a square of theta minus 1. So instead of like cosine of 2 theta, I just put cosine of theta and I get this formula. So now simple algebraic manipulation, you calculate from this formula cosine of theta divided by 2 by simply bringing this 1 to the other side and taking the square root will give you this. Now I can use this equation to calculate cosine pi over 4, which we know already is like a square root of 1 over 2, but based on this equation you can see that it is 1 over 2 plus 1 over 2 times cosine of pi over 2, which is 0, so it is a square root of 1 over 2. And if I continue this way for cosine of pi over 8, I calculate it using exactly this formula again by putting theta equal to pi over 4, but I calculated already cosine pi over 4 is equal to a square root of 1 over 2. So I finally end up with this formula for cosine pi over 8, which has 2 square roots. And continue with cosine pi over 16, which is basically this formula, and then for cosine of pi over 8 I put this whole square root inside here. And if we continue this and plug in all these results to this equation that we had in the denominator for multiplication of all these cosine terms, you finally get what you were supposed to prove. Pi over 2 is equal to 1 divided by multiplication of all these square roots. And that ends the proof. I hope you found this video helpful. You can subscribe to this channel for future videos. You can leave comments and let me know how you solved this problem. You use the same approach or any other comments and suggestions that you have. Thank you.